Hey guys, how's it going? My name is John, and you're watching Leetcode. Today we're going to be solving a Leetcode problem. So this problem is called valid parentheses. It's a pretty common problem that you'll see in a lot of programming exercises. Actually, in most programming interview questions, they'll take a form of this problem and then they'll add some kind of context related to it. But the core principles that you learn on how to solve this problem will come up in different interviewing problems. So without further ado, let's dive right into the problem. Okay, so here's the problem. It's called valid parentheses, and I'm going to just quickly read the problem. Given a string containing just the characters, the open parentheses and right parentheses, and the squiggly one and the bracket one. One important factor about this problem is that it's kind of weird. You'll never see a real string that only has these characters, but for this particular problem, they're assuming that this is the case. And the string is valid if it follows two criteria. Open brackets must be closed by the same type of brackets. Open brackets must be also closed in the correct order. Now, when is this useful? So a lot of times when I solve problems, I like to think about the actual use case. When will we ever check if this type of string is ever valid? In the real world, probably chances are you'll never actually have to do this kind of validation, but a form of this lies in every code editor that you ever use, right? When you open a bracket, let's say a parentheses, to define a function, you need to make sure that function is closed with the following bracket, or the function declaration wouldn't work. So the code editor that you're using, it's essentially doing this type of work, not the exact same, but this type of work on every line change or so. So before I go on, think about the problem, pause the video if you have to, but yeah, just quickly think about it. How would you solve this problem? So for this problem, I'm going to leverage a stack. Now, I probably have to explain what a stack is, and I'll also use some form of a map or a dictionary, depends on what programming language. But essentially, it's a key value store. So before I go too far along, man, I need to explain what a stack is. You know what? I think I have a good idea on how to do this, so I'll be right back.
Elijah, can I borrow this? Thank you. Thank you. Yeah, thank you. Oh, thanks.
Nope. Alrighty. Boom. Oh no! Some hacky way of doing this. Woo! I almost dropped my... So I've drawn myself some open parentheses and the squiggly parentheses, I don't know what they were, in the brackets. So assume that this is a stack, right? So let's say that this represents a string of characters, right? So I'm jumping a little ahead. I wanted to explain to you guys what a stack was, right? All a stack is it's another data structure. And it follows a few properties. And the number one property that it follows is that data that goes in and out of the stack, it follows a LIFO property, essentially. And LIFO means last in, first out. It's kind of like an economics term, I think. At least I first learned about it in economics. So there's FIFO, which is first in, first out, and LIFO, which is last in, first out. So I'm going to demonstrate that using this. So let's say that this went in, and this went in, etc. And let's say you wanted to get this last data point out. The only way to access it is by popping out all of these, and then you have an empty stack and you have access to this. So the number one rule of a stack is that you have a push function which pushes data onto top of the stack, and then you have a pop function which pulls out of the stack. That's super important. That particular behavior and property is actually really important, because using that very tight constructed mentality, you could do a lot of really powerful things. For example, if you ever wonder how your browser remembers the history of your navigation, that browser is using a stack behind the scene to remember where you've been. So let's say you go to google.com and then you click on the link and etc. you go to reddit.com, and then you go to, you know, some naughty sites that you shouldn't go to, and then you go to YouTube, you know, that's a stack. And then now you go out, YouTube, naughty site, Reddit, I forgot what this was, and then Google, right? So hitting the back button. So that's one really use case of a stack in data structure. There's a ton of different things. It's a great place to store memory for some things, but what we're gonna do is we're gonna leverage this LIFO kind of property to solve our problem. I also mentioned that we're going to use a dictionary or a map. And what it is it's a key value store, and it's another data structure actually. The main like principle behind the hash map is that you have a specific value or a key, we call it, that has a specific hash function, some kind of function like mathematical equation or something that when this value goes through this hash function, it points to a specific point in memory, and then you store your memory into that particular value. So this way you have constant time access to whatever key value that you store. So we're going to use these two data structures in conjunction to be able to solve this problem. Let's kind of go back to the problem and talk about the steps, read through the problem again, and then we're going to talk about how to actually solve it, write some code, and maybe I'll show you like a demonstration afterwards. So here's some examples right here. The input right here, obviously this is true, you know, left bracket open, right bracket, right parentheses open, and down here it's also true because you have matching pairs. This is false because you have one that's parentheses and then you have a bracket, and so forth, so forth. This may be like the tricky case where you have equal numbers of you have the correct numbers in combination, in a sense. You have one left hand side, I guess to you guys is the right hand side, and one bracket, and then the like same amount on the other side. But this is not true because right here, when the inner bracket left hand side opens, the immediate one that follows after one it can either be just one of the other left hand sides or a closing right bracket. So yeah, so you can't simply, so what this example for is good to show you is that you can't just simply count how many of the left hand side and right hand side is and see if they match, because there will be this case, in this case it will be false, right? So let's start this problem by just making sure that we have a string, right? So if s not, I guess we could just return true. So the next thing that I'm going to do is I'm going to create a hash map of as the keys, all the keys will be the left hand side brackets essentially, or parentheses, and then the right hand side would be the value of these keys. So luckily JavaScript PostES6 has a syntax for using maps, so we're going to use that here. So let's just call it const equals new map. And there's many ways to create this. The map property, the map in JavaScript has a few nice things. You could pass in like any iterable, essentially data points. So we could do that, and just like here we could pass in like values like so. This I think I'll probably just do this since we know exactly what's gonna go in here. Let me just copy that, paste it over, and then here we're going to do this guy. So one thing that's kind of minorly annoying when I'm trying to make this is the fact that the code editor thinks that, I mean almost all code editor does this, but they do this so that people don't make mistakes essentially. But when you do an open bracket, it will like think that you need the closing bracket as well, because closing parentheses, so it'll do that for you. So now we have this constant dictionary that we made, and we're going to leverage this. And now the next part of the problem is we're going to create a for loop here, and we're going to basically start from 0, and then we're going to say if I is less than s.length, which is a string.length, and then we're just going to go one step at a time. So this is like a linear time. Like as soon as I wrote this, you guys should know that this will be linear time, right? Because we're at least going to see all of the characters at least once, just from this loop. Now, before I go too deep into this problem and finish writing up the rest of the solution, let's go back to my awesome demonstration, and I'm gonna explain to you how I'm gonna solve this problem using my awesome props. So now I'm gonna use these. I hope you guys can see it. Maybe I'll go a little bit closer. Now, I've created an even number of left and right brackets. Not that it matters because I could flip them around like so to match it. And the way we're going to solve this problem is, like I said, we're going to leverage that dictionary that we have. I'll place it right here. Now, this dictionary has a function called has. It has a method called has. And when you pass a valid key to the has function of the map, it will return true or false. If it's valid, if it's in there, it will return. It's very similar to set, if you remember, if you saw the last episode. If you haven't, I highly encourage you to watch the last Leetcode problem episode. So we're going to use that, and we're also going to use the stack. I already explained that stack has a push and pop method, which essentially adds a character. So let's say that we have a string that's like this. Now I'm going to show you an example of a valid string. Let's just do that for now, for brevity's sake. So this is the string. So assume that's a string. Okay, so it's valid. It's basically open parentheses and then the two squiggly parentheses inside. The first step of our program will essentially be, if you see a left-hand side, essentially the key, continue pushing. All you do is you just push that character onto the stack. So as I mentioned, we have the dictionary that has a method called has, so we're going to leverage that. So this one is an open left-hand side parentheses. For you guys, it might be right-hand side, but for me, it's left-hand side. Because when I use the has function on this, it will be returns true, so that goes on the stack. And this is a squiggly one left-hand side, and vice versa, it will go down into the stack. Now the next one is the right-hand side of the squiggly line, like so. And when I place it, instead of pushing it down on the stack, what I'm going to do, this is a second part of the program, is if I find one that's not in our dictionary, meaning the key values are not in the dictionary, I'm going to pop the last item that I put in out and then check if they are valid to each other. Meaning, as you guys know, I put the value of this as the opposite correct matching bracket. So hence, if I check for the value of this key, then this together will be a valid pair. So at this point, I could check if they're valid. If they're not, I could return false right away, right? If this happened to be this, the left parentheses, right? Or I mean the right parentheses. And then I continue doing this, and then obviously the next letter will be this, and it will match. And then the last step I need to do is just check that this is empty, because if there's something still here, then that means there was imbalance, right? So just by leveraging the dictionary and the stack, we're going to be able to solve this problem. So let's go ahead and code that out now. All right, so as I mentioned, the first thing we're gonna do is we're gonna check if the dictionary has the value that we have. And I'm just getting at the index of it by this syntax right here, s open bracket I. Now, if this returns true, then all I need to do is continue pushing my letters onto the stack. Looks like I forgot to build a stack right here. So let's create a stack here, like so. But yeah, so we have the stack, so we just stack that push, and then we'll push that value in. Else, this is the second step that I was talking about. In this case, we have found that the character that we are on is not part of the key set. So let's take the last item that we put on. So let's say, we'll just call it item. That item equals stack.pop, and this takes the last item that we put in out of the stack. So it mutates the stack and then assigns it to the item. And then all we need to do is check if the item, the dictionary.get and then we pass that item in there. Maybe we should just name it key. Key, nah, item is fine. Does not equal the current item, right? And if this is the case, we return false. Now the last thing that we do is if the stack.length does not equal 0, then we also return false, else we return true. So if it gets past all of this, we'll return true. Let me quickly scan. True, return mag. We have our dictionary here, and then we have our for loop. The first thing we do is we check to see if the current character is part of the key list, which is the left hand side of these brackets and parentheses and squiggly brackets. Do you guys know the official name of that? I don't know. And then down here, this is a case when we hit like a right hand side parenthesis, and we'll pop out that item, and then we'll get that item. Yeah, we'll get that item, and we know that that item will always be part of the dictionaries, because the only time we have items getting into the dictionary is so the only time we put things onto the stack is when they're on the left hand side. So we know that they'll be part of the dictionary. And if the value of that item is not equal to the current character, then we can return false, because then that would be this example 4 case, right? So yeah, let's go ahead and run it. Yes. Yes. Hey, there you go, it passed. There's probably ways to like make this a little bit faster, but this is basically how you could solve this, leveraging a dictionary or a hash map, and a stack. So yeah, I hope you guys enjoyed that quick video. I probably need to return these toys. I had a lot of, I don't know. I hope you guys enjoyed that video. Just to go over it, we covered very briefly dictionaries or hash maps. They're also another data structure. We also covered stacks and how to use them. And we covered on validating a parentheses. Now, in a normal program or like a real string, you wouldn't have only these characters, but you could leverage this by modifying this code. You could probably solve for that problem as well. You might need another dictionary for the right hand side as well. But yeah, there's endless combinations of these kind of problems. So I got this question before. This exact question before, but it was hidden in a different form. So the question that I got was like, hey, let's say that we're writing a logging program, a program that logs like functions being called, and this function, when it enters, you need to log that it entered, and then you also have to log that it closed. So what happens if you have like a recursive call and there's like a function that keeps like calls another function and also all etc. etc. How do you properly log this in like a certain way so that you'll be able to see this like kind of nested structure? And I thought a lot about it, and then I realized it just was this parenthesis matching validating problem just hidden in this like different problem context, right? Because when a function opens, you could just imagine that that's one of the open brackets, and then when a function closes, you could just imagine that that's a closing bracket, and there you go, you have that matching bracket. So that, I think I like not telling the story of the problem like very particularly well, but I remember using this I saw this problem before, and I was able to recognize that pattern, that same pattern and that question, and just leverage the question, leverage my understanding of this problem to be able to solve it. And that's all programming really is. All of the things that you learn, these tips and tricks and things like that, when you're solving it, you might think like, man, when am I ever going to reverse a string and, you know, concat this and that and all these like weird nonsense, right? But a lot of times, especially when it comes to leveraging data structures, every day when you're coding in real life, you'll run into it or read code, and you'll be able to recognize these patterns. So it's highly valuable. And like if you want to level up as an engineer, like this is the number one way, is to study your data structures and algorithms. But yeah, I hope you guys enjoy this problem. I know I've been just doing easy problems just to warm up my kind of teaching style, I guess, and also there's a lot of room even in these small easy problems for like teaching about subjects that I haven't taught yet on this channel. But I'm definitely gonna do like harder and harder problems. I probably won't cover any super hard problems because unless I spend like an hour like diving into it, I'll probably need to spend a lot of time like understanding it too. So but yeah, I hope you guys enjoy this problem, and let me know. I've kind of got a rhythm going on right now in terms of like what kind of videos I make. I kind of make like a Leetcode problem, and then I make some kind of like talky vloggy kind of like videos. But let me know if you want to see anything else from me on the comments below. And but yeah, I hope you guys enjoyed this video, and I'll see you guys on the next one.
Back from the dead.